Welcome to the Fazenmeyer Conference. This is our senior capstone presentation. We are ME32, and our project is a cable deployment device for 16 Psyche's surface. I'm Kyleigh.
I'm Ava.
I'm Adric.
I'm Alexia.
NASA's Psyche mission was an orbiter mission to the metal-rich asteroid 16 Psyche in the main asteroid belt between Mars and Jupiter that will arrive in mid-2029 to study the asteroid from orbit. In the meantime, our senior design group has been tasked to design a cable deployment device for a 1-kilometer fiber optic cable for 16 Psyche's surface.
These are some of the technical challenges we've experienced with our project. We have a low gravity environment of 0.144 meters per second squared, which is about 1.4% of Earth's. The terrain is relatively unknown. Managing the cable, general space applications, and the extreme temperatures of negative 228 Celsius to negative 23 Celsius.
The design concept we chose was a standard 6-wheel rover design with a unspooling mechanism inside that would allow the rover to unspool at a constant rate, with a securing mechanism that would prevent the cable from becoming too detached from the surface. This is a 3D model that we have created of this design. The specific components that it was separated into was the suspension, wheel, spool, hook and bolt, and secure mechanism. This is the locations of all of those on the design. The suspension uses a standard rocker bogie system with a differential bar on top to connect the two rockers. The differential bar functions as so.
Here's some technical analysis we did for the differential bar mechanism. Both the fixtures and the side are loaded with a 300 Newton force, accounting for the rover's weight. To analyze the analysis, I did a cantilever beam calculation, and we checked our percent difference, and we can confirm through this that based on the Young's modulus of the material used, which is grade 5 titanium, that the bar will not yield. Then we also did the differential lever, another key component of the suspension. Similarly, I loaded the top fixture with a 300 Newton bearing force. Doesn't yield either. It's great. And then we have the final suspension components. These are just some pictures we have of the equivalent stresses, all of which are well under what we expect.
So for the wheel, it uses a spoke flexure design to connect the wheel hub to the tire, and the rover is capable of turning and steering, as shown in this video. There is the steering, and there is the turning of the wheel. The spokes were the most critical part on the wheel, and so they were loaded with 1,000 newtons to test their strength, and even then, they do not yield and have a safety factor of roughly 2.36.
The spool mechanism uses a passively held spool held on with springs that allows the spool to be interchanged between loadings.
The securing mechanism consists of a drill and bolting mechanism along with swingers to secure the cable to Psyche's ground. Here is a video showing how the cable will move in the securing mechanism. The red line indicates the cable moving back and forth from the swingers, and the hook and bolting mechanism going into the ground. And then the drill animation. And finally, the bolting mechanism animation.
So through this project, we have done as much as we could have in our time, but there are some future steps that will make the rover design fully come together. Those are coding for synchronized motion, such as the rover pathfinding, the gates for the securing mechanism opening and closing, and basically synchronizing everything. some further in-depth FEA structural analysis to optimize the weight, in-depth manufacturing process selection, rover flight configuration and full functionality on Earth, electrical harness design for the rover mechanisms to connect them all, and physical prototyping and testing. So this is our final design. Again, thank you for listening. That was our presentation. Yippee!